Hello everyone. Again, this is your junior high school math teacher, and in this video, we will continue with the discussion of the six trigonometric ratios. Last time, I discussed about the sine and cosine trigonometric ratios. In this video, we will now consider the next two, and these are the tangent and the cotangent trigonometric ratios. Now, in this slide presentation, we have the same set of objectives. State the Pythagorean theorem, and in turn, you define the six trigonometric ratios. At this point, I'm expecting everyone to just consider uh, the first four. Why first four? Because I have already discussed the sine and cosine, and in this video we will consider the next two, the tangent and the cotangent trigonometric ratios. For our next slide presentation, let us consider the right triangle ABC. And in this figure, let us again recall those sides. We know that the longest side, denoted by small letter C, is the hypotenuse, and the other two sides are those sides that form a right angle, and we know that these are the legs. And for each of these legs, particularly this one, the vertical leg denoted by small letter A, is the leg opposite of angle A. And at the same time, the same leg can be labeled as the leg adjacent to angle B. And for the leg, the horizontal leg denoted by small letter B, we can consider this leg as the side or the leg opposite to angle B. And at the same time, this is the leg adjacent to angle A. And from this right triangle with those proper labels on each sides, we can now continue with the definition of the trigonometric ratios. So far, we know the definition of sine and cosine trigonometric ratios. So we will now have the next two. Okay. Again, considering the acute angle A, let us now have the next two trigonometric ratios. The first one is tangent of A, or tangent of angle A, which is defined as the ratio of the opposite leg of angle A to the adjacent leg of angle A. And from the figure, replacing the equivalent symbol of each leg, for the opposite leg of angle A, that is denoted by small letter A, and for the adjacent leg of angle A, that is denoted by C. Okay, sorry. Okay, this is actually equal to the leg denoted by small letter A, which is the opposite leg of angle A, over the adjacent leg of angle A, which is denoted by small letter B. So this is the ratio for tangent of angle A. Now the next trigonometric ratio is the cotangent of A, which is defined as the ratio of adjacent leg of angle A over to the opposite leg of angle A. So basically, cotangent A is actually the reciprocal trigonometric ratio of tangent of A. So by symbol, that is B over A. So meaning tangent A and cotangent of A are reciprocal to one another. Okay? For our next slide, let us now define the next two trigonometric ratios for in reference to angle B. So for acute angle B, we have the following. Tangent of B, it is defined as the ratio of the opposite leg of angle B over the adjacent leg of angle B. Referring to the right triangle figure, the opposite leg of angle B is denoted by small letter b, and the adjacent leg of angle B is denoted by small letter A. This one, okay? And for the cotangent of B, that is actually defined as the ratio of the adjacent leg of angle B to the opposite leg of angle B. In symbol, adjacent leg of angle B is small letter A over the opposite leg of angle B, which is small letter b. Okay? So these are the definition of the tangent and the cotangent of angle B. And with that, and with this, we now proceed to the next slide for some illustrative examples. For our first example, again, we refer to the same problem, the one that I discussed last time, when we are asked to find the value of sine and cosine of each of the two acute angles. Find the 6 trigonometric ratios, or rather find the tangent and cotangent trigonometric ratios for each acute angle in a given right triangle, where C, which is the length of the hypotenuse, is 5, and the length of one leg, denoted by small letter b, is 3. So in this example, actually the right triangle is given with the label given parts. The longest side is given as 5, and the shorter leg, denoted by small letter b, has a length of 3. And obviously from this figure, the unknown side is the longer leg, denoted by small letter a. To compute for the length of this side, we are going to use the Pythagorean theorem, which mathematically states that the square of the hypotenuse is equal to the sum of the squares of the two legs of this triangle. So if we're going to set up the equation by Pythagorean theorem, it goes like this: 3 squared plus a squared is equal to 25. Solving this resulting equation, we have the following solution. So it becomes 9 plus a squared is equal to 25. Transpose 9 to the other side, isolating a squared on the left side. So this is the equation. Then on the right side, 25 minus 9 is equal to 16. Therefore, a squared is equal to 16. And getting the square root of both sides, the left side become a from a squared, and the square root of 16 is 4. So the missing side, or the vertical leg, from this right triangle has a length of 4. And at this point, we already know the length of all the sides of this right triangle. And we can now define the tangent and the cotangent trigonometric ratios of both acute angles. So let us begin with acute angle A. The trigonometric ratios for angle A are the following. Tangent of A is equal to opposite leg over the adjacent leg. When we say opposite leg, it is the leg opposite to angle A over the adjacent leg of angle A. And what is that opposite leg of angle A? That is actually 4. Or small letter a, whose length is 4, over the hypotenuse, which is 5. Or rather 3. Okay? So it's 4 over 3. And for the cotangent of A, that is simply the reciprocal of the value of tangent A. So that is defined as the ratio of the adjacent leg to the opposite leg. So that is 3 over 4. Okay? You just reciprocate the value from tangent of A, you have now the value of cotangent of A. So that is 3 over 4. Now, these two values are in reference to acute angle A. Now, what about the tangent and cotangent of the other acute angle, particularly angle B? So, this time we are now reference to acute angle B, and the and the tangent of B is defined as the opposite leg over the adjacent leg. The same definition as this tangent ratio, but the difference is the reference acute angle B. Okay? So what is that opposite leg of angle B? So that is 3 over the adjacent leg, which is 4. So it's 3 over 4. And for the cotangent of B, that is defined as the ratio of the adjacent leg of angle B over the opposite leg of angle B. So that is actually 4 over 3. Okay? Now for our next slide, let us now proceed to the second illustrative example. So this is number 2. Given theta, which is an acute angle, which denotes an acute angle in a right triangle, and sine theta is given as 5 over 13. Find the remaining trigonometric ratios, or rather, find the tangent and cotangent trigonometric ratios with respect to acute angle theta. So for our solution, let us draw a right triangle and consider the given sine theta, which is equal to 5 over 13. As we all know, the definition of sine of an angle is equal to the ratio of the opposite leg of this particular angle over the hypotenuse. So if this is your right triangle, the longest side can be labeled as 13 because based on this trigonometric ratio, 5 is the leg opposite to angle theta. And I think this leg is the shortest side among the three from this right triangle. So we could label this as 5 here as the length of this horizontal leg. And 13 is the hypotenuse. So among the three sides, this is the longest side and its length is 13. And where shall we place theta? Now, what opening of the acute angle can we place this theta? Now, since this is 5 and this leg is the opposite of angle theta, it's not proper to place theta here because the angle becomes the adjacent of this side whose length is 5. So it means theta should be placed here. Okay? And with that, it is obvious that one side is missing, and that is the vertical leg, which is now denoted as x. Now, how do we compute for the length of the missing side denoted by x? We use what? The Pythagorean theorem, which states that the square of the hypotenuse is equal to the sum of the squares of the two legs from a right triangle. So, setting up the equation, we have x squared plus y squared is equal to 13 squared. And we solve this equation. So 5 squared is 25 and 13 squared is 169. Isolating x squared on the left side, so the right side becomes 169 minus 25. And the result on the right side is 144. Then take the square root of both sides to find the value of x. Therefore, your x is the square root of 124, which is 12. So, this vertical leg has a length of 12. Okay? And with that, we can now define the tangent and cotangent of angle theta. So the tangent and cotangent trigonometric ratios with respect to theta r. This one. Tangent theta is what? 5 over 12. 5 is the opposite of theta over 12, which is the adjacent leg. Okay, and now for the cotangent, we simply reciprocate the value from tangent theta, and that is your cotangent theta, which defines as the ratio of the adjacent leg over the opposite leg. Okay? Now, this is where we end our discussion about the tangent and cotangent trigonometric ratios. And for our next video, we will discuss the remaining two trigonometric ratios. So, we'll see you next time.